A very good afternoon to all. Myself, Alokdeep, Director R&D at Innovative Skill, a startup with collaboration with the NITTTR. Now, I will give you the all the details about the uh, uh, microcontroller programming, Arduino programming, starting from the embedded system, and then some updated version because in this time the many new applications are coming there with the application like Bluetooth, Android phone applications. We want to control all the things with the Android phone. Arduino applications, gyroscope, accelerometer sensor application, 3D printer, because we are learning very fast the new things, and I also want to introduce the things so that you can also update the knowledge by this lecture. So now starting from the embedded system, these are the contents of the my PPT. Embedded system and embedded C, starting from the basics. Now I will not give more time on these basics, but I will give more time on the applications of these things. Okay. Now the microcontroller board, and then Arduino microcontroller board, Arduino Shield. You can use Arduino Shield because if you want many applications board like L293 motor driver, IC boards, then you can make your own shield, or you can purchase this shield specific for like relay driver, motor driver shields, Ethernet shields. There are many of the shields are available in the market, and then hardware interface with the Arduino, and then Arduino programming, basics of the Arduino programming, how you can program the Arduino Shields, Arduino Android programming, because if you want to program your Arduino using the Android mobile, you can program it using the Android app. You don't need any laptop or desktop for the programming. You can program with your Android phone. And then microcontroller based robotic arm, this is the application of the robotic arm. If you learn anything in my way, you have to applicate in on the things. If there is no any application is there, then there is no use of this knowledge. So you can see some projects I have taken here, the solar tracking systems, and cell balancing robot, and line follower robot, and I have the videos of many projects which we have completed in the innovative skill, the startup, and you can see this video, and you can interconnect your knowledge, your teaching in knowledge, because you are a teacher somewhere, then you can connect this knowledge with your previous knowledge with the practical things, how you can use this knowledge on the practical, and how take the applications or give it to the society. The main thing is there. And then MATLAB Bluetooth interface with the Arduino. You can interface the Bluetooth with your Arduino, and you can take the real-time data in your Arduino board. And like this, in the solar tracking system, you can see here. In this solar tracking system, we can take, if it is installed on the roof of the your home, and you want to take the data, what is the voltage producing, the solar tracking is producing presently, then you can take this data in your mobile applications. Okay. You can make this mobile application on the MIT app inventor. It is free of cost. There's no any you have to pay for that. You can make MIT app inventor. This is the site developed by the MIT USA. Then you can program it, and you can make your own app. Okay, there's many apps you can develop for school kids also working on these apps. They are producing it is very simple, and only drag and drop is there. You can have also the tutorials from which you can learn, and you can work. And then MATLAB interface with the Arduino, it is very important thing in the research purpose. If you are doing your MTech or doing your PhD, then during these days you have to learn the MATLAB and LabVIEW, and applications, how you can take the data from the MATLAB, how you can control the things using MATLAB. And then last the LabVIEW interface with the Arduino. LabVIEW also, because in LabVIEW you have the very some predefined blocks. In some predefined blocks you can use it directly, like image processing block, and DSP blocks, and these blocks you can use directly, so that you have not give the time on these blocks to prepare this block. You can directly use, which saves your time. And At first, what is the innovative skill from where I have? I am from the innovative skill, and we have the startup from the NITRRR, and we are working in the three main fields: robotics, entrepreneur, renewable energy, and entrepreneurship development. And now we are entering in the manufacturing of the green vehicle and R&D projects of and consultancy, because in the BTech student, MTech and PhD student, they have the problems regarding the projects, because no one are able to capable to help him practically. So we give the consultancy to the projects. We have the students from the various state, they are associated with us. They take the online help, they come to the lab. So they do very good practical projects here. So this is the about the consultancy by the innovative skill. Now the some basic brief idea about the embedded system is a computer system with a dedicated function with the large mechanical electrical system. You have know already, because you have learned the embedded system. And the main thing is that embedded system in the brief and simplify way, that is the software in the hardware and for a dedicated task. Only in two line we can say the embedded systems like this. Okay. And 99% of the microprocessor are manufactured as a component of the embedded system, because they are used in the embedded system cards for industrial application, or for R&D projects or school projects or other purposes. Embedded C is the language extension for the C programming language by the C standards. And there are some different hardware interface commands are there. Means it is just like a C language, but this only difference is that they are hardware specific. Means we can define the port input output ports, which mean we have to make high or low. I will give you some demonstration also, because I have the board, Arduino Uno and Arduino Mega board, and I will show you. This is the Arduino Mega board. Okay, you can see, here. I will show you the boards. This is the Arduino Mega. Okay, for more input output, and this is Arduino Uno. Okay, this is Arduino Uno. You can see the difference is that the Arduino Mega have more number of pins. It have 53 digital input output pins. Okay, you can see. And in the Arduino Uno there is the 13 digital pins. Okay, and 6 from A0 to A5, 6 analog pins. And in Arduino Mega there is 16 analog input pins. If you want a big application, more number of input output pins and sensor, you have to want to attach the sensors, then you have to use the Arduino Mega. Okay, and the software IDE is same, Arduino IDE. In Arduino IDE you can program it using Arduino IDE, and it is free of cost. You need not to pay anything for the software IDE. From arduino.cc you can write the website arduino.cc, you can download the Arduino software, and then you can program it. Because these Arduino boards are very simple and easy to program. There's no burner is required to burn it, and you can attach it with the Arduino cable easily, very easily, and you can program it. I will show you how to connect it with a USB cable, and then you can connect it like this. USB cable is there, and you can connect it like this. Now the on LED is this is the LED. Now means your board is on, and you can program it using the Arduino IDE. I will show you the later on how to program the Arduino Uno. At first you have to only see what are the main functions of the Arduino and the input output pins. These are the and power pins of the Arduino, and these are the analog pins. These are the analog pins are there. Analog pins, you can take the sensor values, current present values from the analog pins, and you can process it in the in your Arduino. And these pins are the digital pins. You can see here 53 Digital pins are there. These are the digital pins. You can control LED motors and servo motors using these LED digital pins. Okay, and it have more number of pins. You can control more number of input outputs. In Arduino Uno the same thing is there, Arduino Uno, but the pins are less, so you can control or less number of input output. This is the difference with the Arduino Uno and Arduino Mega. In the starting phase, I want to suggest you to start from the Arduino Uno, because it is low cost. You can buy it online or from the electronic shop, and it is a local around 400 to 500 rupees only, and you can purchase it and you can start the making projects, your projects. So, and for programming the Arduino Uno, you can program it using Arduino IDE. Okay, in the later slide I will explain you how to program it. Okay, and I have, because in previous lecture I have explained how to program an Arduino basics all about, but in this presentation I want to explain you some new things which are presently in the market, because students want something new, because they want to project, like I want to use this thing because previously I have learned these things. So I have also added these things which is something new, like USB, like Bluetooth controlled systems, and 3D printer, 3D plotter, self balancing gyroscope and accelerometer applications. Okay, now I am going to the microcontrollers. On the slide you can see, and here you can see the microcontroller here. Okay, now these are the microcontroller. You know the microcontroller is a computer on a chip. Okay, you can see here, this is the microcontroller, because you know all the things, and so I'm not need to go in the deep. Only the application part is important in my side, so I will give you the application point of things using the microcontroller. You can see here, it is the on chip processor, RAM, memory, input output ports, analog to digital converters, all the things are on the single chip, so it is called the microcontroller. And you can make the microcontroller for the embedded system applications. This is the brief difference between a microcontroller and microprocessor. You know, it is a microcontroller it is a single chip, consists of memory, input output port. You can see in the block diagram. Okay, and microprocessor, it is a CPU, memory, input output port to be connected externally. In the processor you have to connect it externally, memory and input output ports. Okay, now this is the microcontroller board, 805 microcontroller board. You have used in the college lab, and the students are using this microcontroller board, but the drawback of this board is that the programming is some tedious work. So you can so Arduino have the existence for this point of view, because the programming and interfacing circuits are tough. So students want, if any person want some applications and less time, and he need not to be go inside the architecture of the microcontroller, only the application parts are there. So here we can use the microcontroller board, it is very easy. And second thing is the burner and programmer issue, because microcontroller board require the burner and programmer issue, and you have to solder all the things, or you have to purchase this board, and some things are necessary, but the all the interfacing circuit are not necessary, and you have to install the software for interfacing with the computer and that board. Okay, and for hex file generation, keel compiler for hex file generation, and then wheeler programmer on another programmer for hex file upload to the microcontroller. So it is a long process. So Arduino is in existence. Some embedded system applications, the PLC applications, and you can see here the lack of knowledge, what will happen. You can see the customer or boss after the lack of knowledge. If so, it is our company's focus that give the practical matters, practical point of view aspect to the students. So this will not happen. Okay, And in the process industry, you can see the example why the embedded system are in the existence. At first, if there is a system, there is no any controller or processor or embedded system, then an operator is required to control all the things. And there is a issue of duty and time and accuracy for the human person and the controllers and computers. So this is the existence of the controllers. Now you can see all the things, yeah, here you can process variable and control output are there. You can see here process variable, this is the process variable, and this is the control output for the control valve. Okay, now control valve is controlling all the temperature of uh, the process. Okay, the process required, for example, process required 100 degrees Celsius, then how to control the speed of fuel. If the fuel is fast, then more temperature, more fire. Okay, so it is important to feedback system which check continuously the temperature of the furnace and according to the speed of the control valve. This is the important thing. So controllers are working 24 hour, and this is the main difference, and with the same accuracy as compared to the human being. So it is important. Now Arduino microcontroller board, you can see there are different Arduino microcontroller boards are there. You can see the Arduino Mega, Arduino Nano, Arduino Mini, and Arduino Duo. There are many Arduinos are there. It is depends on the what the application you need, and how fast you need. If you want the fast applications, 90 megahertz, 80 megahertz application, then you can use the Arduino Duo. And if there is a 16 megahertz crystals is in the Arduino Uno and Arduino Mega. So in the starting period of time, you can use the Arduino Uno board, 16 megahertz crystal, and a student can work in the Arduino Uno. Then they can use, if there is more number of sensors and actuators and control things are required, then the person can use the Arduino Mega board. Okay, and the fast speed, then you can use the Arduino Duo. Okay, then these are the microcontroller boards, but each board are specific for a particular applications which you are using. Okay, because cost matter. At first I want to explain the Arduino Uno board, the basics of the Arduino Uno board, then we'll go on the applications part of Arduino Uno board, because you have to know the basics of the Arduino Uno board, because it is brief basic also. At first I am the USB. Here you can see the USB. From the USB you can connect your computer for programming and power both. And second one is the external power. You can give the external power to the Arduino. If you give the external power to the Arduino after programming, you need not to be connect with the computer. Okay, because but this external power is only for the giving the power to the Arduino board, not for the programming purpose. But USB is for the power and programming both. This is the main difference. And you can give the external power using battery, 9-volt battery, or you can give the power using the external 2.1 mm jack connector, 9-volt adapter. Okay, then you can see the 3.3 volt pin. Okay, now after the external power point, now you can see the 3.3 volt pin. You can take the power from the Arduino. At first you have to understand the difference between the input and output pins, because this 3.3 volt pin is to take the voltage, not to give the voltage. Okay, and the 5 volt pin is, you can take the 5 volt from the Arduino board, because you want to control or give the power to any circuit like LDR circuit or any circuit. Then you can give the 5 volt power from the Arduino board. If you are using the servo motors or heavy load things, then you have to give the power externally, otherwise your Arduino board will burn. Okay, because if you are using the servo motor and it have the load, or stepper motor it have the load, then you have to use the drivers, servo drivers or stepper motor drivers, otherwise your Arduino board will burn, and there is overload on the computer also. Okay, so this will happen. And then ground pins, 2 ground pins are there, and 1 ground pins is the side beside of the 13 number of digital pins. You can see 3 grounds are there. you can connect anyone of, there are internally sort. Okay, you can connect any ground. And then A0 to A5, 6 number of pins. These are the analog inputs pin. Okay, you can take the analog signals like LDR signals, like you, if you want to make a automatic smart light, then you can use the analog pins. Okay, analog pins A0 to A5, and you can take simultaneously 6 analog signals. Okay, and then the controller at mega 328, this is the controller in the board at mega atmal make. Okay, and then 0 to 13, these are the digital pins. Okay, digital pins are there, and the digital pins are some pins are dedicatedly for the PWM. In the PWM you can make, you can control the motors, speed of the motors, brightness, LED brightness, because you can generate the PWM pins. These are the dedicated pins 3, 5, 6, 9, 10, 11. These are the dedicated pins. And pin number 0 and pin number 2 is the RX and TX. We can use these pins in the Bluetooth communication. Okay, TX and RX pins. In the later slide, I will explain you in the detail how we can communicate the Bluetooth. Okay, and the last ground pin is there. This is the ground pin, and this one is the reset button. Okay, in the reset button, you can if you reset the program, then if, for example, you have the 50 lines of the programs, and your program is in any condition like loops, if and else condition, while loop, if you reset the program, then your program goes to the first line of your program. Have any query? Okay, this is all about the brief basics of the Arduino board. Okay, because we have the less time, then we have to focus on the main applications of the microcontroller embedded system. So now these are the steps you can note down or you can see. And to program the Arduino, at first you have to download. There's no need to install. Now the new versions, there's no need to install. Only you have to download and copy the setup. Okay, and the Arduino IDE, and then connect your board to the computer via USB cable. Okay, and then Arduino IDE, and then select your board. You have to select, you are choosing your Arduino Uno or Arduino Mega. Okay, if you are not selected the board, then there is error, uploading error. Okay, so you have to select, because Arduino don't know you which board you are using, because many other boards are there. And then select the board, select your serial port on which USB port you are connected your USB device, and you have to select it. Okay, open the blink example. At the first example, I also explained to the students that you have to start from the blink example, because the using the blink example you can check how your microcontroller board is communicating or not. Okay, so you can check the using blink example if there is, and change the timing of the blink example also, because if you program one time Arduino board, then the program remains in the microcontroller. Okay, microcontroller, and if you want to change the program, the second program is overwrite on the first program, and first program is erased. Okay, so the last program you have copied or uploaded on the board, it remains the same in the Arduino board until the next program you are not copying on this. Okay, then this is all about how to program the Arduino, and this is connect your board to the computer via USB cable. Okay, and select your board. Okay, these are the steps. Okay, okay, and now you can connect it using USB cable. Okay, this is the USB cable you can connect. I will explain step by step how to program. At first you can see the slides and how to connect it. Okay, and the steps you can note down, because students and persons confused and which option I have to select. And you can program the Arduino with other software like MBlock also, because in the school we have trained the students like LKG 1, 2, 3, 4. They are also using the Arduino, and they program the Arduino also using the MBlock. MBlock, it is a software designed by the MIT USA also, Scratch and MBlock. So using this MBlock, they play the like puzzle game, drag and drop, and they program the Arduino LED blink examples, analog read, and then make the obstacle detector robot also. because presently our workshop is going in the DAV school, and their students are making the M block programming. Then you can write down the M block. It is a very small software you can install, and you can program the Arduino using drag and drop. If your kids are interested to learn the programming using fun, then they can start from the M block. Okay, and then their programming skills are improved, and the basics are clear in the school level also. Then they can do much better in the college level. Okay, so M block. And now you can see the steps of programming of the Arduino. At first you have to go to the tools. You can note down the steps. You have to at first open the IDE. Okay, Arduino IDE, then go to the tools. Okay, tools, and then to the board. Okay, board. In the board you have to select Arduino Uno or Arduino oblique Genuino Uno, means Arduino Uno. You can select Arduino Uno because I am using Arduino Uno, yeah, I have to select Arduino Uno. If I am using Arduino Nano, then I have to select this. Okay, which the board you have selected, the pointer comes to the that board. Okay, here the Arduino Uno is selected. Okay, understand? Clear? Is all the concept is clear? Okay, the first step you have to connect, select the board. Second step, now you have to connect the port. Okay, after connecting the Arduino board, because if you are not connected the Arduino board, then port is not come here. Okay, after connecting the Arduino board, you get the port, and COM port 6, oblique Arduino Genuino Uno. Okay, then you can get the Arduino Genuino Uno, means the at COM port 6 there is Arduino is connected. Okay, and if there is no Arduino, then if you can there is blank is there. Okay, now you can next step is the exam file. Okay, the two step is completed. First exam step is to select the board, and second step is to select the COM port. Okay, now I am trying to check my Arduino board is communicating with the computer or not. Okay, for checking this Arduino board, I have to go to the examples. Predefined examples are there. No need to write the program in the starting. You can learn from the starting, and then you can make the new programs. Okay, so for checking your board is communicating, working properly or not, you have to go to the file. Okay, file, then example, then basics, and then blink. Okay, you can note down the file, then examples, then basics, and then blink. Okay, in the blink example, you can upload the program of blinking of the LED at pin number 13. Okay, pin number 13, at the pin number 13 is inbuilt LED. You can program it for checking the my board is communicating properly or not. Okay, only the 13 pin is there in which the inbuilt LED is there. If you don't have any LED, then how to check your board is communicating or not? Then you can check using the pin number 13 LED. Okay, and 13 13. Okay, I will show you how to check after these slides. I will show you the practical demonstration. Okay, okay, now this is the blink example. You can see 13 to in the blink example, you can see the void setup and pin mode 13 output. Okay, in the void setup you have to define the input and output pins, which pin you want to input or output. If you want to blink an LED, then it is output. Okay, if you want to read something, then it is input. So if in the example, this is the output pin, because at the pin number 13 we want to blink the LED, and you can switch any transistors, and then can switch the relay, and then you can switch the motors or fan, or using optocoupler you can control the heavy load also, 440 volt, 1000 volt amperes. Okay, using this Arduino board. Okay, this is the main cheese. And then digital write 13 high and delay 1 second, and digital write 13 low, 1 second delay is there, and it is in the loop, means it is repeating again and again. If you are in the void setup, you have to define all the pins and input output things, and in the void loop the program you want to repeat again and again. If I want to blink my LED, then blink means high low, means 1 second high, 1 second low, 1 second high and 1 second delay, then 1 second off and 1 second delay, then it is repeating again in the loop, then it is like blinking. Okay, and this is the steps. You have to upload the program. To upload the program, you have to click the arrow, then the program in the Arduino IDE, it uploaded in the Arduino board. Okay, and hardware interface with the Arduino. In the hardware interface Arduino, you can give the input transducers, and it can take the signals inputs from the analog values or any physical parameters, and it will convert it using analog to digital converter, and then it gives you the to the computer or anything you want to display on the LCD or anything. Then you can take. Now presently we're working on the IoT in the lab. So on the IoT you can access the data, like you are in the USA and you want to see the data, what is the reading there, or you are in the USA and you want to take the temperature of this room, then using IoT we done this. Okay, so this is the, you can use the Arduino Ethernet shield, and it is connected with the Ethernet cable, and it communicating with the net, and you can access the current real-time values using the IoT. And these are the main things for the IoT. And the IoT in the present thing, it is very important and very current topic, because students want to done their thesis and projects in the recent topics, because time is changing and technology is also changing. So these are the recent topic, like 3D printing technology and Internet of Things. These are the topics in the students are very interesting, and we are going to give a summer training, in the summer training from 1st June in the Innovative Skill in the Nature campus, in which we are giving these trainings, IoT and 3D printing and Arduino programming, robotics. So now you can program the Arduino, and I will show you physically how to program it. And at first you have to select the Arduino. Here, this is the Arduino IDE icon. Okay, you can select the Arduino IDE icon. Now this is the Arduino IDE. Okay, now you have to select from file. Okay, I want to uh, upload the program, the blinking program, then file, then examples. Okay, then basics. Okay, then blink. This is the blink example. Okay, in the blink example you can write it, because in the 13 as a output sorry, and 13 as a high, 1 second delay, 13 as a low. Okay, you can see here it is now visible. Okay, void setup. In the void setup there is a pin mode 13 comma output, means I want to use the 13 number pin as an output, so I defined it in the void setup. Okay, now in the while loop I want to blink the LED again and again, so digital write 13 comma high. Okay, then delay for 1 second. Okay, delay for 1 second, and digital write 13 comma low, delay for 1 second. Okay, now the second step, I want it the board. For example, I am using the Arduino Mega board. This is the Arduino Mega board. Okay, this is the Arduino Mega board, and I have selected here the board Arduino Mega. Okay, now the port is not coming there. एक मिनट रुक जाइए. The port is not coming there. There's no port. Okay. Now I'm going to connect it. Okay. Now I'm connecting it. I've connected this. Okay. Now the port will come. Now the port will come. The port is come. Okay. What is this? COM22 Arduino Uno Mega or Mega 2560. Okay. I've selected it. Now I want to upload it. I want to upload it. Okay. I want to upload it. Okay. Now for uploading this. Okay. For uploading this one is for the uploading, the arrow one. Now it is going to upload. Okay, 1 second high, 1 second low program. Okay, now compiling the sketch. This is the processes are there. Compiling the sketch. Okay, it is compiling in the laptop. After uploading, you can see the blinking of the LED. Okay, compiling the sketch. It is compiling presently. Okay, compiling. Okay, uploading and done uploading. Okay, now you can see the blinking of the LED. Okay, this is the blinking. Okay, 1 second delay, 1 second on, 1 second off. If I want to change the time, if I want to make it faster, then I am going to make it 200 milliseconds on and 200 milliseconds off. Okay, this is a 200 millisecond on and 200 milliseconds off. Okay, now compiling the sketch in the laptop. Now uploading and done uploading. It is changed now. Okay, you can see the timing of the LED is changed and it is blinking fast, 200 milliseconds on and 200 milliseconds off. Okay, this is the basic thing I have used. Now I want to change it, the Arduino Uno board. Okay, once again I'm going to change it. Now I have connected Arduino Uno board. Okay, okay, this is the Arduino Uno board, the starting one. The starting, your students of your college or institute can start from this Arduino Uno board. Now I have to connect it at COM port Arduino Uno. I have to select the board. I have selected the board Arduino Uno. Now it is not blinking. Now I am going to upload the program. Now it is uploading, compiling the sketch. It is not blinking. Compiling the sketch, uploading, and in the process. It is in the process.
Have you changed the board?
Yeah, I have changed the board. I have changed the board Arduino Uno, because if I have not changed the board, then there is issue in the uploading the program. Okay, if there is some issue regarding to the COM port, you can check at the device manager. Okay,
सेटिंग में वहाँ ऊपर टूल्स पे बोर्ड
Okay.
नॉट सिलेक्टेड
ये पोर्ट यहाँ पे,
बोर्ड
yeah,
बोर्ड
okay, okay, I have to change the board here. Okay, it is some issue. Yeah, if I have not changed the board, then there is uploading error. You can see also the uploading error. Then I have changed the port but not the board, so it is error in the uploading. So I have changed now it. Now it is compiling the sketch and now going to upload. But there is also some error regarding some done uploading. Okay, now it is, you can see here it is blinking now. Okay, you can see. So if you have to change the port and board both, if they're not changing, then some error in the uploading. Compiling is perfect, but in the uploading there's miscommunication that the board is Arduino Uno or Arduino Mega. You have to check all the things. Okay, now I want to give some project videos. You can see the project videos in the PPT. Okay, then you can get the ideas of which type of project you can make using this. Okay, one by one. I will give you the project videos. Now you can see this one is the my thesis project I have completed in 2016, and you can see here that the robot can detect the color, shape, and can pick and place the object according to the where you want to place. If you want to place the green object at the left side and red object on the right side, or in the bucket, you can place accordingly. Okay. The application is in the industries, the color detection, biscuit industries, and the robots are used there. Okay, I have made this using the, these are the power supply units. You can see here power supply units, and the robot is moving, and color sensor is downside where the object is placed in the starting. In the downside, you can see when the object is placed displaced from this place, and the ultrasonic sensor is used. Two ultrasonic sensor array is used for x direction, y direction, for checking the shape of the object. The shape of the object is cylindrical, rectangular, or triangular. It can be checked using the ultrasonic sensor array. By measuring the distance from the object, it can calculate which object is there. It is object specific. If objects are different, then we have to change in the coding. Okay, so for triangular it is triangular object, or rectangular or circular, it depends. Okay, this is the video. You can understand what are the application of the Arduino board, microcontroller board. These are the applications, and I have another videos, and this video you can see here. In this video you can see the automatic cutting, automatic drilling of applications, in which when the object distance is less than a particular centimeters, then the drilling is will start, otherwise there is no drilling. What is the advantage of this thing? Power consumption and accidental, less accidents, because if it is on continuously, then there is less more probability of accident. Okay, if when there is required, then the drill is start, then power consumption and less accident probability, the two main facts, main key points of this project. Okay, now you can see, you can see here the LCD, which will show the distance of the object and the setting. I've set this distance the 5 centimeter, means the object is closer than 5 centimeter, then driller motor will start. Okay, and there's the power supply unit is there, you can see, and Arduino Uno and motor driver. The on the PCB board you can see the motor driver IC is there, motor driver IC, because Arduino signals are 5-volt signals, and I want to control a motor which is 12-volt, 24-volt, 9-volt motors. So it takes the signal from the Arduino Uno and it converts it in the high voltage signals. It takes the voltages from the battery or adapter, and it take the signal values like 5050 to the 12012 to the motors. If 50 is the signal input from the motor driver IC, the output is 120, means at the 50 the motor is clockwise, then at 05 motor will be anti-clockwise. So we can change the direction of the rotation of DC motor using the Arduino programming. Okay, the next video of the project is it is the MATLAB based robotic arm control. This robot is placed in the embedded system lab in the electrical department. You can see it is the MATLAB Simulink applications. MATLAB Simulink you can control using the MATLAB Simulinks, in which the stepper motors are used, 5 stepper motors, and the gripper is the pneumatic system. It is air compressor is used for the pneumatic system, and it will grip the things using pneumatic pressures, air pressure. Okay, the payload is 22 kgs. Payload is 2 kgs. 2 किलो तक ये weight capacity है इसकी, और it can place the object at any directions. Okay, so you can change the angle values of the stepper motor using the MATLAB Simulink command. Okay, and then you can upload the program. Okay, and the robot work accordingly. This is the MATLAB application of the robotic arm. And now you can make a frequency measuring system. This is a frequency measuring system in which I have used the one Arduino as a frequency generator and one Arduino as a frequency measure. Okay, measuring device. Okay, now this is the frequency you can see on the serial monitor of your laptop. This is the 1 megahertz frequency. Okay, so you can make a CRO, means a CRO device using the Arduino, because at one I have cross checked this frequency at 1.1, means 1 megahertz frequency, and I am taking the values of the frequency, and this is the frequency 1.1 is from the Arduino. Okay, I have cross checked these frequencies, means Arduino is giving the right frequency or any error values, or how much the error is there. There is no error there. It is measuring a very accurate frequency, 1 megahertz. From kilohertz to megahertz I have checked it on in the lab. So you can make as a project of in the, if there is a diploma student or then BTech student, they can make like this project, frequency measuring device using Arduino. So it is not important the how much the bigger circuit or lesser circuit. The important is the concepts is important. So on which concepts the student is working, it is doing the work on itself or it is purchasing from the market, because the students will not able to work or don't have any technical knowledge, they are very suffered, and they will go to the market and they want to purchase the projects, but it is not a good thing, because they, by this they are not able to understand the concepts of the technical knowledge, and they suffer after their completion of the diploma and BTech. They have not capability to take a job because they don't have any technical knowledge. So you force them to work. It is a hard step, and it is a very tough path, but it reaches to the good goal. So now next the project you can see, it is a line follower robot. You can see here line follower robot, it follows the black line, and there are 5 IR sensors are there. 5 IR sensors are checking continuously, it is on the black line or it is on the white line, and then the programmer is the Arduino board is used in this circuit in these projects, and analog input and digital inputs are used for the IR sensors, and you can check continuously the values, what is the difference and how the fluctuating the values, and it give command to the motors to rotate clockwise or anti-clockwise or left or right accordingly. So for different values of the path and different curve, it have the different movements of the motors, so it will follow the track. This is the main thing. This is the student can make the line follower robot, and you can print the thing like a thermal printer or mini printer. You can print like this. This is using Arduino. You can print like this. If you want a receipt, like in government bus, you have the ticket from the printer, so just like a small printer is there, only 2500 rupees. And if you want a receipt from the data, then you can take the receipt from this printer. Okay, no ink is required, only thermal printing is there, only one time investment is there, and you can take a receipt also. Okay, these are the new things the student can make, because they want to update the things time to time. And the next thing you can see here is the pick and place robot. You can see here the pick and place robot. This is the pick and place robot. The 6 servo motor are used here. You can see the programming of each angle for the 6 servo motor is a very tough job. Synchronization and all the things, how it will pick what is the angle of the first motor, what is the angle of second motor, third motor, you have to calculate all the values. It takes 1 days to set all the values. Sometime there is some mistakes, then robot moves in other direction, and the big object is you have to calculate the exact angles. You have to interlink the mechanical part, programming part, and electronics part. So you have to interlink all the things. So your programming skills, your mechanical design skills, and electrical electronics skills, all the skills are used in the multidiscipline project is there. Robotics is multidiscipline. So in the training we have always give the student to the robotic project. So each skills are used in the robot. So nowadays the multidiscipline skills is very important. So multidiscipline skills and multidiscipline student can work together to make a very good project. So this thing is there. And you can see the self balancing robot project. The robot which is self balanced, you can see it is self balancing using PID controller. The student will learn the PID controllers, but they are not able to application in the robot, because Honda is also launching a bike like self-balancing bike, which is self-balanced. Okay, so the technology is used there, but this is the basics. The student can learn the basics and then apply in their products. The students, some students are entrepreneur, they are making their own projects and they are selling their own projects. They get the investment from the rich persons, and they are making their own companies, own industries. So if the student have the spark, you have to give the spark to the students so that they can do a very good job. Okay, this robot is balancing on the two wheels, and you can see here this is the self balancing robot. Okay, self balancing robot. Okay, so I have made this video. Okay, you can see the self balancing robot in how will it look, and you have also seen the video of the self balancing robot. This is the self balancing robot. Okay, it have two wheels. Okay, two wheels, and it will balance on the two wheels. And this is the sensor, accelerometer gyroscope sensor is this is the accelerometer gyroscope sensor, MPU 6050, inbuilt accelerometer and gyroscope, very small sensor. And yeah, you can able to see this is the sensors. And it have VCC ground, SDA and SCL pins. Okay, SDA and SCL pin, SDA, SCL, VCC ground. You can see here very small sensors. And this is the Arduino shield. You can see this is the Arduino shield. Okay, this is the Arduino. This is the applications of the Arduino. You can see this is the Arduino. Okay, and motor driver IC and wheels also. Okay, this is the motor driver IC. This is the motor driver IC. Okay, you can see here this one is the motor driver IC, this one is a motor driver IC, this one motor driver IC. Okay, and this is the two motors, DC motor I have used for movement purpose. You can see. Then it takes the signal, from the MPU 6050 accelerometer gyroscope, and from SDA and SCL. SDA is connected to the A4 and SCL is connected to the A5 in the analog input pins. I have explained you the analog input pins. These are the analog signals, and SCA is connected to the A4 and SDL is connected to A5. Okay, and one pin is VCC 5 volt and one is the ground. Okay, so you can take the signal simultaneously, data from the gyroscope accelerometer. The Arduino is taking the continuous data. If it is moving forward, it is, then the motor will move the forward, and if it is moving backward, means the balance is shifting to forward, then it is moving forward, and balance is shifting to backward, then it is moving backward. And now it is balancing it at a certain condition, taking the all the parameters P, I and D controllers. Using the P, I and D controllers, I am changing this value of the P, I and D controller using the potentiometers. Okay, I have learned the PID controllers basics and the practical application of in this project. I have worked from very in the last year from in this project. I have worked continuously for 10 days, and after that within 10 days I am not able to find a solution how to balance it. And after a long time and long practice, I have taken these things and find the solutions how to control a self balancing robot. This project learned me many things, how to control, how to use the PID controllers value, because I have learned in the BTech and MTech the PID controller, but I don't have the application of the PID controller. And this is the application of the PID controller. And using this controllers, you can it is very fast controller, because in the on off controller which are generally using in the projects, on off controller is a very slow controller, and it is jerky, means jerk is there. We are trying to at first I'm trying with the on off controller, but it is not stabilized this robot. So after which I have used the PID controller, and then this PID controller is make this robot to balance it. Okay, and yeah, one video is another video is there. Okay, you can see more balanced aspects this in the PID controller. Okay, in this you can see more balanced structure, means setting at first I have set the I values, then P values, and then D values, then it is stabilized at this condition. Okay, and you can also make a self balancing bot with a weight, and moving forward backward or moving to a destination. It is some more applications, controlling with your laptop or mobile, anything. Okay, now the last one project video I can you can see is the solar tracking system. This is the solar tracking system. Okay, you can see the solar panel is there, and solar tracking system is the system which tracks the where the maximum solar energy is there, and it track accordingly. And 4 LDR sensors are used here. You can see here 4 LDR sensors. Here 4 LDR sensor, and the top, bottom, left, and right. These are the top, bottom, left, and right. Okay, you can check. And then when the movement of sun is there, then light is shifting from one LDR to another LDR. At the time, this light on the one LDR is first LDR is more, and the second LDR is less. So the for example, there is the sun. Okay, and the light on this LDR is more, and this LDR is less, means sun is there. Okay, with here is the more light, either is the less light, the solar panel is moved like this. Okay, and this it is tracking it. It is 4 axis tracking, x axis and y axis. Then 4 axis quadrant tracking system is there. You can uh, make it this is the motor driver IC. You can see in the video motor driver IC Arduino Uno I have used here. Arduino Uno, two motors. For x axis is one motor, for y axis is one motor. Okay, and for power source I have used the battery, and you can charge the battery also with the solar panel. Okay, and Bluetooth module for communicating. I have explained already. Then you can take the real time values of the solar panel. This is a panel voltage, because it is in the tube light, so panel voltage is less, 0.01, 0.2. When there is flash on the solar panel, then it is 0.2. No flash, 0.01, 0.02. And in the daylight it is around 8 volt, 9 volt. Okay, so you can see here the movement. I'm making it like on one LDR is dark by keeping my finger on the LDR, and okay, then one side is light. I'm giving the flashlight from the mobile, then it is moving like to the light, facing the light. This is I'm stopping the light at the LDR using the finger, and giving light to the other LDR with the mobile light, generating the artificial environment like in the. Okay, this is the solar tracking video. Okay, now again coming to the PPT. These are the videos are important because I want to give you the application point of view. It is important. Now again to the PPT, and now Arduino programming basics. You can see the void setup and while loop. I have explained earlier in void setup and while loop. Okay, in void setup, they only once executed, and in the void loop, infinitely executed. Okay, it is executed again and again. So it is the void loop. If I want, for example, I want to blink LED, I want to rotate the motor continuously, then I have to put it in the void loop. If you're writing this command in the word setup, then it is executed only one time in the starting. Okay, then void loop is executing again and again. Okay, this is all about the setup and void setup and void loop. Okay, and then if else conditions. If else condition is very important condition in the programming, because for example in the solar tracking system, if the light on the first LDR is more, if the light on the second LDR is less, if the light on the third LDR is, if else conditions are there, and we are you have to work on the if else conditions and logics, else if conditions. These conditions play a very important role in the programming, and it is not a very big issue and not a very tough task, because the students are thinking that I am not from the computer science engineering branch and it is very tough to program the robot, and I am not able to work on the robotics and all that things. So it is, you have to say that a student okay. Is it possible practically? Yeah. By tracking the solar system. Yeah, it is practically, and I have made this project. Intensity of the light. Yeah. Is not very much. Yeah, in the natural environment, na? If you are saying you are asking a very good question. If in the early morning, when the sun is in the east, okay, and in the evening time when sun is to the west condition, then in the winter and summer, the solar energy, sun energy track, solar sun track is like in the winter, it is like this. If south to north is facing, if your home is facing south, for example, you are facing the south. Okay, then sun's direction is like this. Okay, in the summer like this. Okay, this and this two tracks are there. If at the small instant of time, like 5 minutes, there is no any variation. You are saying a very good question, and it is, but it make a effect when there is gap of 2 hours, 2 hours or 1.5 hours, because in the 15 to 21 there is no variation is there, because almost there same light on the LDR. Okay, when there is the 2 to 3 hours is elapsed, then there is the variation, because one time sun is there and one time sun is there. But in the 5 to 10 minutes there is no much variation, and you can adjust the in the coding also, because we calculate practically, and in the programming the threshold value, and in the programming I make it 2, means left sensor and right sensor, the difference is 2, means the value which is digitally coming from the LDR, the maximum difference is 2. If you can make it like 0.1, but then it is more sensitive. But in when it is more sensitive, then it is more unstable also, means always fluctuating like things. Okay, हाँ, बहुत ज्यादा फ्लक्चुएट करने लगता है, तुरंत एकदम डिसीजन लेता है, मान लो हल्की सी छाया बादल आके गया तब भी मूवमेंट लेने लगेगा। हाँ, तो इस चीज का भी हमें ध्यान रखना पड़ता है कि अगर थ्रेशोल्ड हमारा 2 से 4 से ज्यादा हो, और कुछ टाइम के लिए वो चेक भी करे, मोमेंट्री कोई अगर पक्षी ऊपर से उड़ के गया तब भी वो मूवमेंट लेने लगा, तो ये सब चीजें भी हमें ध्यान रखना पड़ता है। एंड यू हैव टू कीप इन माइंड दैट these things, as a programmer you have to think and think again and again and all the aspects of your coding. Otherwise, your coding will be fail in the environment. So this is the thing. And very good question, sir. And now you can write like if analog value is greater than threshold value, this is the threshold value. Okay, you can make it like 2. For example, generalized coding is there. You can assume that from this or anything. Okay, threshold value. Then digital write id pin high. Id pin high means you have to make the digital pin high, and with digital pin you can make rotator motor or blink led, anything you want. Okay, or you want to light a bulb or fan, it depends on you. You get the 5 volt and we have to convert accordingly. You want to trip or you want to on a relay or transistors, this depends on your circuit. Okay, now you can see here Arduino shields. You can see the Arduino shields. Okay, Arduino shield, Arduino in Arduino shield, you can use the dedicated input and outputs, dedicated input. Using this dedicated input and output, you can control like servo motor shield, stepper motor shield, and Ethernet shield. This shield can be attached on the top of the Arduino. Like this is they are male connectors, and Arduino jumpers are, these are the female connectors. Okay, the male connectors are less like yes, इसके ऊपर ही ऐसे लग जाएगा. ठीक है, और फिर उसमें जो सर्किट रहेगा वो उसके हिसाब से वर्क करेगा. ठीक है, तो उसमें हमारा मोटर ड्राइवर भी हो सकता है, इथरनेट शील्ड भी हो सकती है. ओके, these are the things. Okay, now you can see the Arduino shield. And Arduino shield, they are like relay driver circuits are there. You can see the relay driver circuits. Okay, now multifunctionality of the Arduino can control the DC motors, stepper motors, servo motors, and you can take the data. You can interface with the MATLAB, LabVIEW, many R&D activities you can do with the Arduino. Because when you are a multidiscipline engineer, or you want to make a multidiscipline project, or any mechanical person want to make a project like 3D printing, then it is very tough to learn all the 8051 programming, PIC programming, assembly level programming, C programming. It is very tough to learn these things. So it is possible to use the Arduino directly with the shields or with the 3D printing or anything you can use using this. So it is a multi-functionality of the programming, and there are some libraries are available there. Main important thing is the library, because when you get the library, the work is less. Okay, some programming, some coding part is defined in the library. You need not to write all the coding, because in the 8051 when you code for the LCD, there 2 to 3 page code is there. If you are using the library in the Arduino, there is half page code in the Arduino. So it is a thing, and it is easy, but there's some negative point also of the Arduino. Negative point is this: it is when the student is using directly the Arduino, and it is not want to understand the logic behind this, then it is a gap between the real knowledge, means the inside functionality of the system, and the working of practical things, and the theoretical inside functionality of the system. He is not able to understand how the LCD is working, how the data is going to the LCD pins. Okay, enable pins. So what are the enable pins? He don't know. He only know to connect the Arduino with the LCD and make the LCD writable. Okay, anything print you can print. Okay, now Arduino Industries, these are Arduino shields. You can use the Arduino shield, and these Arduino shield are dedicated for the industry purpose. You can make the card, like you can connect this card with the industries, and you can take the output, and you can control the industrial processes parameters. Okay. Okay. मैम टाइम कितना है रिमेनिंग? रिमेनिंग टाइम कितना है?
14 minutes.
14 minutes. Okay. Even you can use the Arduino. You can see here the industrial application of the Arduino. You can see in the slide. Okay. Now Arduino Android programming. You can program Arduino using directly Android phone, and you can control. These are the steps you can see here. You can see the Arduino Droid. This is the Arduino Droid. On the top, in the middle, the symbol you can see the Arduino Droid. In the Arduino Droid is a mobile app using you can program the Arduino. Okay, you can write Arduino Droid. Okay, Arduino Droid, and this is the window after using the Arduino Droid. First window, you can see Arduino Droid, and you can is get these icons: sketch, file, edit, action, setting, tool, purchase, help. ठीक है. Okay, then you can select the board type and app setting. Some things are very easy here, like you have to connect the Arduino Uno, Arduino CS340, which Arduino you are using, like in the Arduino IDE in the computer. uh, okay, like that, and it's very easy. And I have also the video of these things, because we have the channel of our company. The you can write down in the last slide. I will show you how you can get the channel and how can you learn from the channel, because I am not available all the time. And if you want to learn anything, you can learn online. If your student is far away and he want to learn Arduino or programming or project, he can learn from our channel. Okay, and there's 10,000, around 10,000 views of our channel. Okay, in the last slide I will show you. Okay, and this is, you can see the basics, digital and law communication basics. Blink example is also in Android app version also. Okay, this is a Blink example. You can upload this program to the Arduino board. Okay, and now microcontroller based robotic arm. This is also application of the embedded system. You can control it microcontroller using robotic arm. Now you can see the gripper of the robotic arm. This is the gripper. It is servo motor based. The two servo motors are used. Now software used, I will go some fast because less time is there. And you have to use the software Arduino Uno. You can use the MATLAB Simulink for the 3D animation of your robotic arm, and robo analyzer also. In the robo analyzer you can animate your robotic arm, how movement. Okay, and this is the simulation on the MATLAB, the robotic arm simulation on the MATLAB. These are the link. This is picking the object 3 link robotic arm, and this is the simulation of the robo analyzer. Okay, you can simulate the robotic arm before going to the hardware. You can simulate on the software, so you can check how it is working or not. If any issue is there, you can check it. Okay, so, and now this is the complete assembly of the intelligent robot. You can see here the 6 degree of robotic arm is there. Okay, this is the 6 degree of robotic arm. These are the color blocks. Okay, TCS 3200 color sensor is there. This one is color sensor. Okay, ultrasonic shape detector, because this system will check the color and shape also. For checking the shape, the ultrasonic sensor, and for checking the color, it is TCS 3200 color sensor. Okay, and Arduino Mega is used. Okay, you can see this one is Arduino Mega, and this one is the power supply. A power supply also a big issue for this project, because there are 6 servo motors. They draw more current and more power. So I have made the power supply differently. A 2 ampere power supply for the servo motors, dedicated 1 ampere for the servo motors, and for half ampere for the Arduino board, and rest of the sensors for the sensors. Okay, because previously I have used one power supply, then there is some problem, current problem, less current in the circuit and not working properly. So I have made 2 power supplies. For servo motor is a dedicated power supply for the servo motor robotic arm. Okay. Now you have also seen the project video of the drilling machine. Now it is the Bluetooth communication with the mobile, and you can check the real time value as I explained in the video, that you can check the real time voltages value of the solar panel in your mobile app. This mobile app can be developed in the MIT App Inventor, you have written there. Okay, and you have to connect the Bluetooth with the Arduino using these four wires. You can see four wires, very easy connections. VCC with the 5 volt, ground with the 0 volt, and TX of the Bluetooth with the RX of the Arduino opposite, and RX of the Bluetooth with the TX of the Arduino. Only this connection you have to make. And when you write in the serial monitor of the Arduino, okay, it will take the values and it will send it to your mobile, and you can see the real time values. My what the voltage is there in the solar panel, and what is the temperature of your room, and you can control your light, fan, etc with your Bluetooth mobile app. Okay, like this Bluetooth module takes the command, and Arduino can control the relay 1, relay 2, relay 3, how much load you want to control. Okay, step to connect Bluetooth, take the real time values. Okay, connect with the Bluetooth. When you are using the app, this when you connect with the Bluetooth, there is SC05, it is the name of the device, Bluetooth device SC05, and in which it is communicating with your Arduino. And if you are connecting with the SC05, you get the real time values. Okay, now MATLAB Simulink, you can also interface the your Arduino with the MATLAB also, with the MATLAB Simulink also, and you can check the connectivity with the MATLAB. And with the Simulink, if you are using the MATLAB Simulink model with the communication with the Arduino, you can use the target installer. You can write down the target installer. This is the command you have to write in the command window and then enter. Then it will automatically this window will pop up, and then you can install the Arduino as I have shown in the slide. You can install the Arduino, Beagle board, Lego Mindstorm. These are the boards. You have to select the Arduino because I have installed already. Then it is the action is reinstall option is there. If you are not installed, then it is install option. Okay, then it will download the necessary communicating file, supporting file from the net, and your MATLAB is capable to communicate with the Arduino. You can take or give the data, or you can control using MATLAB of to robotic things or any other things. Okay, then these things are there. MATLAB controlled, you can make the MATLAB controlled robot. Now lab view, in the lab view you can take the signal processing toolbox and the other toolbox. Using the lab view, make DAC cards, but they are costly. Lab sensor, the college students can use the Arduino. They have to communicate with the lab view. They can use the lab view software, and then that they can take the values in the computer. And or if you want to take the real-time values in the Excel sheet, there's also a command plxdaq. I have the software. If you are interested, I will give you. Using this software, you can take the real-time value like the temperature values of this room. You can take in the Excel sheet directly, and if you can use in your projects, you can use in the thesis, in the higher studies you can use. Okay, so these are the things. PLXDAQ. PLXDAQ. This is the software by which you can take the real time values in the Excel sheet directly. Okay. In the lab view programming, you can check here the connectivity with the lab view is okay or not, the blocks are available or not, input output, and all the things you have to control. Now you can check that smart load scheduling system hardware applications of the embedded system, okay, in which we have the prototype system for the Homi Bhava blocks, director office, and mass canteen. These are the critical, some are the critical loads, some are non-critical loads. You can check when there is presence or not, all the thing, and accordingly the light is on or off, okay. And this system is based on the lab view, okay. You can take the real time values in the lab view, okay. And solar tracking system I have explained earlier, and you can see also the hardware here, and in the video I have explained it how it will work. This is the block diagram of the solar tracker. The charge controller is there, battery, solar panel. The servo motor is attached with the solar panel. For x-axis and y-axis, LDRs take the signals and give to the Arduino. And in the algorithm written in the Arduino, you can see it will take the decision where the servo motor have to move. And these are all about the solar tracking system. And these are the main components: LDR, solar panel, servo motor, PIC microcontroller. Any microcontroller you can use, PIC 8051, Arduino, it depends on you. And this is the our channel, because आप लोग रहते हैं दूर और चीजें प्रॉपरली नहीं मिल पाती है, तो इसमें क्या आप लोग चैनल के थ्रू देख सकते हैं चीजों को. So these are the 138 subscriber of our channel, some of from the USA, Australia, and 9,165 views of our channel. And you can check, or you can type the innovate skill projects. You can write down innovate skill project in the search window of the YouTube, and the channel is open. And you can see the video. There are 11 videos are there, in which the Arduino embedded system, robotics, all the programming, how the board is working, all the concept is clear. Some lectures are for 5 to 10 minutes, some are from of 1 hour also. So these are the all about the presentation. And one thing I want to say, that we are going to conduct a workshop in the June for the engineering student, diploma student, and you can tell to your students, then they can join, and we will teach them from basics to the IoT and 3D printing also. Okay, thank you.